Good morning. I want to give you guys some examples on how to predict chemical reaction outcomes. So before we start, let's remind ourselves of the 6 types of chemical reactions we're focusing on this unit. And that is, uh, writing is difficult. That is synthesis, decomposition, combustion, single displacement, double displacement, and then a type of double displacement reaction, which is acid-base. Okay, so let's go through an example. Let's start with synthesis because that's the simplest. So for a synthesis reaction, let's do an example of I have hydrogen gas and fluorine gas. If I see this reaction, H2 plus F2, and I have to guess what the outcome is going to be, well, I see 2 individual elements just combined together, only bonded with themselves. So that to me means it's going to have to be a combination of those 2, and we're going to end up with 1 compound at the end, making this a synthesis reaction. So I know it's going to be some combination of hydrogen and fluorine, and I'm going to need to remember my bonding rules in order to figure out exactly how this bonds together. So the charge for hydrogen is plus when it's ionized, and the charge for fluorine is just minus when it's ionized because hydrogen needs to steal or give away an electron to be happy, only 1, and fluorine needs to steal only 1 electron to be happy and have those full outer shells. So we only need 1 of each type of element. So in this case, we are actually just going to have HF. Okay. My next step would be to balance this equation because we don't want to create or destroy any atoms. And the only thing I need to do is put a 2 out front because then I have 2 hydrogens and 2 fluorines. So that's a synthesis reaction. Let's do a different reaction. Let's go the opposite direction and do a decomposition reaction. So if I have, let's get back to red. If I have NaCl and then I have the arrow and I have to predict what is going to be the outcome of this reaction, I would say to myself, oh, I've got 1 compound on my reactant side. That means on my product side, I need these 2 elements separately. So that means I'm going to end up with Na plus Cl. Let's start with the Cl. I need to figure out how it's going to combine with itself in order to be stable. So if I draw a Lewis structure for chlorine, 5, 6, 7, and I do that for another chlorine, 1, 2, 3, 4, 5, 6, 7 valence electrons, I can see that there's a lonely set of electrons right here that can be shared. So this can become chlorine and chlorine covalently bonded together with those 6 paired electrons going around it. So this means that chlorine bonded with itself is just going to be the molecule Cl2. So I can put a 2 here. Now let's think about sodium. Sodium has 1 valence electron, and if it's going to be by itself, to be happy, we have to get rid of this electron. So we're going to assume that that electron is donated somewhere else. We don't know where, and what we're left with is an ionized version of sodium because we don't want to bond the metal with itself. We don't see that with sodium very often. So I'm going to just put a plus here to say that this is going to be an ionized version of sodium and not just sodium bonded with itself. That way we don't have to figure out how that molecule is going to look. Okay, so now I've got my final result. NaCl makes Na plus Cl2. Now I've got a balance. The easiest way for me to balance would be to put a 2 right out front because I have 2 chlorines on the product side, but only 1 chlorine on the reactant side. And then since I have 2 sodiums on the reactant side, now I need a 2 on the product side, and then I'm good. 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. Okay, so that would be a decomposition reaction. I started with 1 thing, and I ended with 2. Let's do another type of reaction. Let me just try and erase all of my dots. That's going to take me forever. Oh my gosh. We'll do all this stuff. Say goodbye to all this work. We just want to keep the other stuff, and we'll just ignore the dots. Dots are too annoying to deal with. Go back to my red. If you saw in front of you the elements or the compounds C8H18 plus O2, and you have to predict the outcome, what kind of reaction do you think this would be? Well, I see oxygen, and I see like a combination of carbons and hydrogens. So this is a fuel plus oxygen gas. So that means that those two things together, we're going to have fire, we're going to have combustion. So what are my two products for combustion? Well, there's CO2 and H2O. And that's the only way you can do combustion, is those are always your two products. Erase this stuff so it looks pretty. Now I have to balance. This one's kind of a bear to balance, so I'm just going to put the final result at the end. If you want to see how I did it, ask me, email me, or ask me in class. But we're going to need 2 of those C8H18 molecules. We're going to need 25 of these oxygen gas molecules. We need 16 CO2 molecules, and we need 18 H2O molecules. So that's going to give me 50 oxygens on both sides, 16 carbons on both sides, and 36 hydrogens on both sides. And notice that I cannot reduce this, because even if I divide 18 and 16 by 2, 25 can't be divided by 2 in a whole number. So this is the lowest way that we can balance this equation. Okay, let's do another reaction. Erase this stuff. My red. And then let's do Ag and O3 plus NaCl. What's the outcome going to be on this one? Well, I have an element combined with another element. So I've got one compound, and an element combined with another element. I have another compound. So if I see 2 compounds on my reactant side, that means I should have 2 compounds over here, making this a double displacement. So if it's double displacement, that means I'm going to switch places on the metals. So I know that it's going to be NaNO3 now in some combination. We'll figure that out in a second. Plus AgCl in some combination. We'll figure that out. Okay, my metals just switched places. Now I got to figure out how these elements are actually combined to make a compound, and we need to think about charges. So the charge for sodium is plus, just +1, and the charge for nitrate, this NO3, is actually minus. So those are going to combine together. 1 minus 1 is 0, so it's already neutral. We don't need to add any subscripts to this one. We have silver and chlorine. Silver has a charge of plus. It is one of the few transition metals that has a consistent charge. And then chlorine always has a minus. So 1 minus 1 is 0. This is already neutral. We don't have to do any subscripts down here. But we do need to balance, so let's double check. I've got 1 silver on the product side. I've got 1 silver on the product side, 1 silver on the reactant side, 1 nitrate on this side, 1 nitrate on this side, 1 sodium on this side, 1 sodium on this side, 1 chlorine on this side, 1 chlorine on this side. So we lucked out. This one does not have to be balanced. So our final answer would just be sodium nitrate plus sodium chloride creates sodium nitrate. Did I say sodium chloride? Silver nitrate plus sodium chloride makes sodium nitrate and silver chloride. Okay. And then I've got another one for us. One more example. Erase, erase, erase. Whoever thought of stroke eraser is beautiful and a genius, and I love them. It's made my life so much easier. If only the dots would erase easy. Okay. One more reaction to look at, and that is I have HCl, and then I have O2. So if I look at this reaction, I see, okay. I've got a compound, and then I've got a lonely element. Oxygen is only combined with itself. So that to me means I should have another compound plus another lonely element on the other side, making this a single displacement reaction. However, this one's kind of tricky because even though I can figure that it's going to be the chlorine by itself, because the anion, which is hydrogen, is going to transfer over to, or no, the cation, oops, the cation hydrogen is going to transfer over and bond with the other anion that we have in our equation, because chlorine's an anion and oxygen is an anion. I don't know with what combination hydrogen and oxygen will form. So let's start with the chlorine. We know the chlorine is going to be by itself. So we know it's chlorine, and we know for previous experience that it's going to be chlorine bonded with chlorine, and it's just Cl2. But then we have some sort of combination of hydrogen and some sort of combination of oxygen. And there are lots of options, and we don't know which one it's going to be. It could be H2O, or it could be H2O2. Both of these are possible covalently bonded molecules for hydrogen and oxygen. So if this was an exam, I would take either answer. Okay, I would take either one because there is no way for us to guess which one is going to turn out with the knowledge that we have from this class. So I'm just going to pick one, and I'm going to go with H2O because who doesn't love water? And now I've got to balance my equation. So that means since I have two hydrogens over here and one over here, I'm going to have to account for that. But then I've got two chlorines over here, But then I have this one oxygen on the product side and two over here. So that means that I'm going to end up, I'm not going to show all my work. You can ask me if you want, with 4 hydrochloric acids, 1 oxygen gas, 2 H2Os, and then 2 chlorines. So I have 4 chlorines on this side, 4 chlorines on this side. I have 4 hydrogens, 2 oxygens, 2 oxygens. Okay, so this would be my final one. So if you ever get a problem where you have to combine into a covalent molecule, then yeah, there's going to be options, and you're just going to have to take your best guess, and I'll accept a few different answers. Okay. Hopefully this has been helpful and you can see some examples and get some ideas on how to predict those chemical reaction outcomes. See you guys in class.